Hello, everyone. Welcome to our webinar, Run Big Data and Machine Learning Workloads at Scale with EC2 Spot. This is the third and final webinar of this series. The first one talked about Spot overview and best practices with autoscaling groups, and the second webinar was on optimizing container workloads with Spot. My name is Aparajita Jas. I will be the moderator for this one. With me, I have my co-presenters, Alex Joseph, Kinar Sen, and Pritham Pal. We are all part of the AWS EC2 Spot go-to-market team. Some housekeeping items before we start. The session is for 2 hours with Q&A at the end. But if you have questions during the presentation, feel free to ask in the chat window. We do have team members present like last time who can help answer. You will be on mute by default until we get to the live Q&A at the end. Next slide. We have a packed agenda for this session. For the first 1 hour or so, Alex and Kinar will cover the big data portion of the session. We will start with a recap of Spot instances that was covered in more detail in the earlier ones. We have customers running both managed services, big data workloads in the form of Amazon EMR, as well as self-managed tools such as Spark with Yarn and Spark with Kubernetes on Spot. We will cover the best practices of both and end with a demo of Spark on Kubernetes. Then we will transition to the machine learning section of the session with Pritham. We will start with an introduction to machine learning, talk about the AWS AI/ML stack, what are the benefits of running SageMaker training jobs on Spot, and finally talk about how some customers are running containers with Amazon EKS for ML workloads on Spot. Similar to the last couple of times, we have a short quiz, which also has Amazon gift cards as prizes for the top 3 winners. So please stay till the end. Finally, we'll open it up for the Q&A. Over to you, Alex.
Thanks, Aparajita. Hello, everyone. My name is Alex Joseph. I am part of the EC2 Spot business development team in the Bay Area. So as Aparajita mentioned, so we will start with a quick recap of Spot, and I guess you're mostly familiar with it. Either you attended previous webinars or you have heard about it, but I will recap in a couple of slides, and then we will transition to big data workloads and applying Spot for it, and then handing over to self-managed big data later on. So let's do a quick recap of Spot. So EC2 Spot instances are really a purchase option for Amazon EC2, and the infrastructure is exactly the same as on demand. So it's not really a different product. And everything that you would expect from EC2 in terms of security standards, the instance type options, and the regions and availability zones, they're all available in Spot. So there is really no difference on that count. What's different is that it's spare capacity. So because of that, you get a really attractive discount, up to 90% of on-demand is available, depending on supply and demand. And the only trade-off is that it's interruptible. So you are ready to let the instance go if there is a demand requirement from on demand. But we will talk to you more about it later on, how you can manage it, and especially for big data workloads, how that interruption risk can be mitigated. But end of the day, it gives you an opportunity to get a lot of scale at a fraction of the cost, and that gives you options in compute and then get results faster. And then if you're a startup, essentially it helps you accelerate your path to a market and then really extend your runway. So this is why Spot instances are especially interesting for startups, but it's also used by enterprises and a lot of our big customers. So we'll talk about some of the key principles of Spot instances and how it works for big data workloads. So the simple rules of Spot, we already talked about Spot infrastructure being the same as on-demand and RIs. So there's no difference there. And we get this 70 to 90% off discounts, and there is no commitment. So that's one other key difference. So if you get an RI, yeah, you get discounts, but you are making a 3-year commitment. So that's Spot doesn't require any commitment, and you can use it whenever you need to, and you can scale up and down. And the price is really based on long-term supply and demand. The changes are smooth and it's infrequent, It's not, and there is no bidding. So you might have heard about the bidding process of Spot. So Spot is not new. It's been around since 2009. So during the early days, Spot had a bidding approach, but that is no longer the case for more than 2.5 years at this point. So no other customer can outbid you by having a higher price. So none of those things are true anymore. So this is just a price set by EC2 based on long-term supply and demand. So at the very minimum, I hope you take that away from this presentation, that there is no more bidding strategy for pricing. So there are interruptions, and that's a Spot is an interruptible service because it's based on spare capacity, as we talked about, and it only happens when on-demand needs capacity. So it's not like another customer is outbidding you, but it's just that on-demand needs capacity. Again, it only happens when that specific instance type in a specific availability zone, what we refer to as capacity pool, if that specific pool has a requirement for more capacity, then you might get interrupted. But the way to solve that is exactly the last point. It's around diversification. So Spot has a lot of capacity. I mean, Amazon EC2 has a lot of spare capacity across the board. So if you are flexible to choose different instance types and availability zones, you can find capacity. And this is what we are going to tell you more about in the context of big data. And you probably heard that in the context of other workloads in the past. And that's really the key principle of Spot, diversification. So think of it as like a stock portfolio diversification. You are really reducing risk because the probability of all of them going down in the Spot scenario, if you pick 10 or 20 instance types, the probability of you not finding capacity in any of them, and if you multiply it by the availability zones, the probability becomes really, really small. And that's the key principle by which you mitigate the risk of interruptions and handle Spot workloads. Having said that, Spot is an interruptible workload and interruptible service, and for that reason, it's best for stateless, flexible, and fault-tolerant workloads. And this is where we'll talk a little bit more about big data and machine learning workloads. Okay, so again, if you have any questions, please add it on the chat window, and we will respond to you before we get to the live Q&A. So let's now talk about big data and why big data on AWS. So as many of you are probably familiar, AWS provides a lot of tools for big data analytics applications to be built, and they are quite comprehensive, and the breadth and depth of the tools portfolio, everything from data ingestion to storage on S3, or data processing on EMR, or data warehousing through Redshift, or a lot of the purpose-built databases that we have. It gives you the right tool for the right job depending on your need. And this is why there are a lot of options, and it's AWS portfolio for big data and analytics. It's comprehensive and open. And they have these options. And clearly, we have a lot of managed services. And today, we will talk a lot about Amazon EMR as an example. But then you also have, for any reason, if you want to run open source frameworks such as Hadoop or Spark or others in a self-managed fashion on EC2, you also have that option. And that's something which we will also cover today. So again, both the managed service options such as EMR as well as self-managed big data options are available. And even if you work with ISVs on the AWS Amazon EC2 platform, that's also an option. So we will talk briefly about that as well. So let's dive a little bit deeper into the big data with EC2 Spot. How is it so relevant and so applicable? The need for big data solutions, as you all know, the data is proliferating. There's a lot of data, whether it's from sensors or from devices. It's proliferating, so you really need to process it, and you need compute for that, and you need to be able to scale and at a low cost, and you also need to provide high performance. And all of those things could make big data expensive. And even when you come to the cloud, which has a lot of advantages in big data processing, you have some of these challenges. And at the same time, big data has some unique characteristics. It's fault tolerant, flexible, and it's distributed because of the parallel processing. And this is where there is a natural alignment with EC2 Spot, which is optimized for stateless, fault tolerant, and loosely coupled workloads, and where it can be a great fit. And this is why we think applying Spot for big data workloads can result in lower predictable prices, faster results, and an easy to use experience once it's integrated in services like EMR. So that's really the key here, because it's a natural workload which is aligned with the cloud native principles of processing big data workloads. And this is where Spot can really help you lower your cost and scale very quickly. And the core principle, again, just to emphasize that point, it's really the parallelization, right? So you are really reducing time to insight. And in the first picture, you see this scenario of a job running for 10 hours, and you have a certain number of parallelized nodes. Let's say it's one node, but then you can multiply it. You can just scale it up, and then you can get the job done faster. If you, let's say you apply 10 nodes, and then you are reducing the job running time. And then if you apply Spot instances on top of that, you can, with the same budget, you can get a lot more data processing done. Or if it's a different, if you want to have cost savings, you can also have cost savings, or you can have a mix of both. And this is why the big data processing with Spot becomes a natural fit, because of the ability to parallelize your processing and take your tasks independently, whether you are using any of the open source frameworks that let you do that, from Hadoop and Spark, and it makes a huge difference for you in terms of the cost and the ability to scale. So now let's talk specifically about Amazon EMR, and then talk about some of the best practices and how you do it. So I hope most of you are familiar with Amazon EMR. It's a managed service that gives you the opportunity to have 21 open source projects such as Hadoop and Spark and Hive and many others, and in a fully managed way. You don't have to worry about cluster setup and provisioning. And you get this, everything is tested and maintained for you without you having to go through the heavy lifting. And then you get the latest and greatest from the community within 30 days to the release. And that really simplifies the experience. And of course, you can use S3 as storage. And this is where we will talk about the practices of decoupling compute and storage, and then how you can use especially EC2 Spot instances to scale on the compute side, but clearly using S3 securely with a very high degree of reliability and durability, and using the high performance with EMRFS connector. And we'll talk mostly about the reduction in cost with EC2 Spot, and you can also do it with reserved instances. And this is a key advantage for EMR, because Amazon EMR has invested in making the Spot integration seamless and made it really easy for you, so that a lot of the things that you would otherwise worry about are already taken care of for you in terms of ensuring the resiliency, in terms of recovering from interruptions. So we'll talk about some of those specific areas later on, but just wanted to give you a glimpse of what EMR is and how that can help you in a managed service scenario. Okay, so just a quick recap. I won't go into much more detail. I'll switch to best practices in a moment for Spot, but just to make sure we're all on the same page, the Amazon EMR has multiple node types, and the one is the master node. It manages the cluster. It's the resource manager. It monitors the health of the cluster, and you can run it on an instance fleet, and then we will talk about that later. And the other two types are core nodes and task nodes. So it's probably worth discussing it a little bit. So the core nodes runs tasks. You can run executors in it, but it also stores data in the HDFS file system on your cluster. So clearly, our general recommendation when we talk about Spot is put master and core node on demand, and then task nodes, which we'll talk about in a second, on which is pure compute, and put it on Spot. So core, again, when you can also use EMR and you can use S3 as your storage layer, in which case you may not need that many core nodes. Again, it depends on their application, but take a close look at it, how many core nodes you really need, because you have the chance to scale your compute using task. And task nodes only run task, and they're pure compute only. They don't store data in HDFS, and they are optional for sure. But you get a lot of value by using task nodes to really scale up your compute. And even if you look into EMR on the console, you will see that it's in the quick options, you will see only master and core, because you can start a cluster just with that. But if you go to advanced options, again, from the console experience, you will see task, and then you can add task nodes to it. So again, a couple of key takeaways for you to think about. Put master and core on demand, and task on Spot is what we would recommend. And then also, think long and hard how many core nodes you really need. Even you put core nodes on demand, there are possible, at least one is required, because that's where the application master runs, even for a single job. But beyond that, you need to think through, do you really need many, or can you get your job done through having more and more task nodes in an instance fleet format? And then we will talk about that in a second. Good. So before we go to best practices, I just wanted to show a couple of customer examples, very successful customers who have optimized cost with EMR and Spot instances. One is Salesforce, and other is Zillow. Hopefully you are familiar with both of them in different contexts. Also, Salesforce has a Audience Studio product, and that's Salesforce Audience Studio. That's part of their marketing cloud. And what they have there is a data management platform, and that requires a lot of data processing from a lot of different channels. Salesforce helps its customers drive digital personalization, and then they collect a lot of data from all of the interactions the customers or consumers like you and me have, and then segments it into different profiles, and makes it easy for their customers to get to know their end customers. So that obviously requires a lot of data processing, and what they have a lot of transient clusters, thousands of transient clusters running every day, and they save 80% versus on-demand pricing, and this is pretty significant, and they have found a way to move more than 80% of their compute to Spot instead of on demand, and that's a great success story. And then we continue to work with them, and then there's a quote from here about how Salesforce manages capacity changes and manages the overall infrastructure growth, also leveraging Spot with EMR. And Zillow Group is another case study. Again, you probably know Zillow with a lot of real estate property listing sites. There is obviously a lot of big data processing that happens in understanding the home values, and Zillow uses EMR to run Spark and Hive jobs, and what they really do is, what they have found in this experience was that Spot instances are not on 24/7, so you don't have to commit it, you don't have to run it all the time. You can solve the problem when you need to, you run the job. And they also found out that the cost differential is significant, close to 70% compared to on-demand, and even compared to 3-year RI, it was close to 30% savings. So again, those two examples, there are several such customer examples, but just wanted to give you a sense for the usage of EMR and Spot in a real world context. And again, they are using a few best practices, and which is what I'm going to talk to you about next. But these are not very hard. As I said, EMR already makes application of Spot experience much easier for you. And then if you're aware of a few of these best practices, you have the opportunity to drive similar results and cost savings as some of our best customers. Great. So let's talk about the best practices of Amazon EMR on EC2 Spot. There are only 5, as I said. There are many things EMR takes care of for you in improving the resiliency, but let me just pick a few ones that you can influence, and you can make sure that you have the best experience. So I will talk about all of them in a little bit more detail, but just to summarize, there is a Spot Instance Advisor page that will help you select instance types looking at the past interruption rates. And then you can also look at older generation ones. That's a kind of a tip that you can use, because sometimes they have more availability and less interruptions. So if that works for you, that's great. And we already talked about using Spot for task nodes and using EMR instance fleet with instance type diversification. So instance fleet really enables the key principle of Spot, which is diversification that we talked about. And instance fleet has had some recent innovations where the number of instance types that you can have has gone up from 5 to 15. So that gives you even more of an opportunity to diversify. And if you need auto scaling, use managed scaling. That's again a new recent last innovation that came out last month with EMR. And if you combine it with instance fleet, you have the opportunity to auto scale. And then if you are using Spark, right sizing your executors not to make it too huge will also help you. So let me walk you through 5 of these, and then we will wrap up and move to the self-managed section. So a Spot Instance Advisor, you might have probably seen it in other contexts. You can just do a Google search, and then you will see Spot Instance Advisor here. And what it really tells you, again, you can check this box about instance type supported by EMR. It shows you the frequency of interruptions. Again, this is a snapshot of the previous 30 days, and it's a rolling snapshot. It changes, and then you can pick your region, and you can pick your needs from a vCPU and memory, and then you will see the instance types, and then that'll give you a starting indicator at least in terms of which instance types that you want to pick. And again, as I said, use many is the key recommendation, which we will talk about. But that's an option, and also look at previous generations. So if you can look at sometimes you only do R5 for memory optimized work for big data. Some of the customers do that, but maybe you should look at R4 too. And then you might have the options to get savings as well as lower frequency of interruptions. So that's one practice, which is pretty easy to do. You look at it, and then you incorporate it as part of your fleet. And Spot for task nodes, we already talked about it in general terms. This introduces a little bit of a nuance, saying that if you have a long-running cluster and data-critical workload, so you can definitely still go with the same recommendation on demand for master and core and task nodes for Spot, but you can even fine-tune it by having a mix of Spot and on-demand in your task nodes. Even that's possible with EMR, and that gives you an added level of comfort if you want that. But at the same time, if it's a pure testing workload, and if you are extremely cost sensitive and you don't really mind rerunning it, if anything, the worst case scenario happens, you can run everything on Spot as well. So I just wanted to point that out as an option. So let's talk about instance fleet in a second, in instance fleet now, because EMR offers you the chance to either pick a uniform instance group or instance fleet. So uniform instance group lets you pick only one instance types. You can have multiple instance group for sure, but it's not a fleet with multiple instance types. So instance fleet really gives you the chance to have the true Spot diversification. And when you do that, EMR you can do it for all of these, but it's probably most relevant for you in the task instances scenario when you really build a large fleet and you probably need many nodes and you need high capacity. And EMR takes care of any interruption. When the interruption happens, it will look for another node to replace it, and then the job will continue. Worst case, you may have to recompute a certain portion if it's Spark, but it's inherently resilient because of that reason. And then the more instance types you add, the more opportunity you have to diversify and have a better experience with Spot. And as I mentioned earlier, it used to be 5 instance types, and that has just recently been raised to 15. So you can have up to 15 instance types. So if your workload is flexible, and again, take a closer look at your application and not just be tied to a specific instance type that you've been using all along. And if you have that flexibility, it opens a lot of possibilities for you. Again, in the beginning, you can even look at multiple ACs, but even when the cluster is running, it can look at multiple instance types within that AC, and that's a big plus for you, and have a better Spot experience. So that reduces the job runtime impact from Spot disruptions, as we talked about. So one more recent EMR innovation that came out last month is managed scaling. So managed scaling is very exciting. It really makes the auto scaling capabilities simple and then extremely fast. So the managed scaling can respond to demand within less than 10 seconds and help you save up to 60% on costs. And from a Spot perspective, the interesting path here is that managed scaling is now available for instance fleet. The classic auto scaling was available only for instance group. So now you have the opportunity to apply both managed scaling and instance fleet. So if you have a long running cluster, you can still, and then it needs to go up and down in scaling depending on the workload. You can really use managed scaling with combined with instance fleet with how much ever instance types that you can have, whether 10 or 15 that you can add to it, at most 15. But that gives you a lot of options. And managed scaling also simplifies the process. It just, you just need to say, this is the minimum number of units, this is the maximum number of units that I expect, and then this is the maximum number of core. And that's it, and EMR really takes care of the scaling experience for you. It's a really fully managed experience, and combined with instance fleet, it makes the Spot experience even better. And this is a new feature that we are excited about. So here, this one I'll just briefly mention. It also EMR also released this new feature around capacity optimized allocation strategy. So what that means is that EMR looks at the deepest pools of capacity anytime it needs a Spot instance. And in the beginning, and also whenever it has to look for, whenever there is an interruption, and then it looks for across all of these instance types, and it replenishes the cluster with the deepest, from the deepest capacity Spot pool, which means that your chance of getting interruptions really get minimized. And it also does the lowest priced on-demand instances when you have a mix of on-demand and Spot. But that's a pretty cool allocation strategy. You can just enable it, whether from the console or from the CLI or SDK, giving the permission for EMR cluster to enable that strategy. But that's again making that experience better, and then giving you the opportunity to dive deeper into the deepest capacity pools, as I said earlier, combination of instance type and availability zone, and that can help you get the best Spot experience with EMR. So this is the last best practice, and then we will transition. So this is really applicable for Spark, and obviously the earlier scenario was applicable for auto scaling needs. Similar to that, this is really for Spark. And what it means is that when your applications are coupled to a specific instance type by asking for high memory executors, your options of diversification essentially become smaller, and that's then your ability to. So if you want to be flexible on the instance type, which is the core component of diversification, right? It's the core principle, as we talked about. You need to be willing to have different numbers of vCPU and memory. But if you lead in with a very high number of cores and very high number of very high memory needs, and your options of instance type kind of become limited. Again, EC2 has a lot of instance types, but even then, if you ask for 16 cores and 72 gig memory, for example, that can limit. And what that really means is that even if you find the instances, you might there is always a chance that there is a higher chance of getting interrupted if the capacity is limited. And in general, this is not a Spark best practice anyway to ask for to have a very high memory and core requirement. But the key thing is that you be flexible with instance types and maybe look at the optimal CPU to memory ratio. So instead of saying 16 to 72, and then see if that probably corresponds to 1 to 4, and then start with smaller executor size. And if you define that, there is a lot more options that you would have in terms of instance type, and that will help you also reduce the number of interruptions and then have more capacity availability. Again, diversification is the key theme here, right? So the more instance type that you can be flexible around and expose and then make sure that the cluster can utilize a lot of those different instance types, the better Spot experience you would have, because you would have access to a richer set of capacity. So if you limit yourself too much, then that's a risk. So that's really the intent. Again, it's a Spark best practices. So if you recap real quick, I know I went through a lot of stuff, and some of you are familiar with some of the things, hopefully. But hopefully it still helps, because these are not super complex things, and these are simple best practices you can keep in mind. And when we had discussions with customers in the Bay Area, we have seen that after some initial discussions, they've been able to apply some of these very quickly and move significant amounts of compute to Spot instances and be able to scale quickly. So keep that in mind. These are not rocket science. So again, look at the Spot Instance Advisor to get a sense for the instance types, and still you still need to diversify. You don't want to go with just one, but at least it'll give you a collection of instance types. And then number 2, utilize Spot for task nodes. We talked about that. And then probably the key is really using EMR instance fleet, because that will help you diversify along the Spot instances. And then, as I said, with the 15 instance types available now, you have a lot more options to do that. And again, if you need auto scaling specifically, managed scaling gives you a great option in conjunction with instance fleet. And then we talked about right sizing your executors now. So hopefully you'll have a great experience with Amazon EMR using Spot instances. And at least I think that if you are using EMR and if you're not using Spot instances, very likely you are leaving some money on the table. So this is something that you can, this is a best practice that you can come in and apply quickly, and then again save or scale quickly, and then contribute. So I think that's something which is interesting. But at the same time, as we started, we recognize that customers have options, right? They have choices. So you can go with managed services, you can go with self-managed big data options, which we will talk about in a moment. But they also have options to go with ISVs. So we also have partners such as Kubol and Databricks that we work with. And for example, recently Kubol published this blog on the APN, our partner network, about how they're using EC2 Spot instances on the Kubol data platform for their end customers. And similarly, Databricks makes it possible for their end customers to use Spot instances. So that's something that's possible. You can still use Spot instances with ISVs. And if you are an ISV who's working with, who might be able, so we work with a lot more ISVs beyond these two in big data and other workloads. So if you're an ISV that's interested in using Spot instances for yourself or for your customers, we would love to talk to you as well. So that's really because Spot is something that can help you regardless of your choice across the spectrum of managed services, self-managed, and ISVs. All right, so let me thanks everyone, and I will hand it over to Kinar to continue the discussion on self-managed big data.
Thank you, Alex, and good morning, good afternoon, and evening to you all. Let me share my screen and let me know if you can see it. Can you see my screen? Can you see my screen? Hello?
Yeah,
Yes,
we can see your screen.
Okay, yeah, thank you. So today I'll cover self-managed big data on AWS as a part of this event. So as Alex just covered EMR in details, so EMR is going to be the right answer for the highest value in most of our customers' big data journey. However, many start with a self-managed way, a self-managed big data on AWS for their Hadoop workloads. And that might be for a variety of reasons. One of the reasons might be the need to move quickly. So lift and shift approach can acquire the fewest changes to the software, and they can just, whatever they're running on the on-premise, they can just come and run it on AWS. Or there might be a variety of other reasons. The key point here is AWS's wide range of services for compute, storage, serverless, security, and containers makes it the ideal choice for running self-managed big data workload. And some of those services that you can see on the left-hand side of this slide. In the diagram on the right, what you see is some of the most popular and commonly used open source and CORS tool to run a big data pipeline, right? Like we have a Kafka, we have Flink, we have Redis, we have Spark. So an end-to-end pipeline with open source and CORS software can be easily built on AWS with unmatched reliability, security, and performance. And one final takeaway from this slide is the cost optimization and scalability can be realized through the use of EC2 Spot instances. So next, I'll move on and I'll talk about scaling an EC2 Spot. And through an example, what I'll try to show you is that how you can lower your runtime and your cost on your Hadoop workloads while you use EC2 Spot instances. So consider that you have a 10-node cluster running for a particular workload, and it runs and it completes in 14 runs for 14 hours. The cost of each node is $1, so total cost is around $140. You decide to add 10 more nodes on Spot to the same cluster. So what happens, the immediate impact is that the runtime reduces by half. So now you have a 20-node cluster running for 7 hours. So now the total cost is 10 nodes running for 7 hours on demand is $70. And then the Spot with the reduction of prices, we'll have $5.5 into 10 running for 10 nodes running for 7 hours is 35. So overall you have $105. So what you achieve here is you get 50% less runtime, and your runtime gets halved from 14 to 7, and you are actually spending 25% less. The cost comes down from 140 to 105. So next is what I'll try to show you here is how by decoupling compute and storage, it is much more, it's ideal for EC2 Spot, and this is one of the best practice or recommendations that we ask our customers to follow while they're running big data workloads. So consider you have a cluster node where you have compute and storage in a single box, and that node is interrupted due to Spot interruptions, which is by design. You not only lose the compute, you'll also lose the data which is in that node. However, if you are storing it externally, decoupling the compute and storage and store it in something like an Amazon S3, even if you lose the compute, the node, the machine, the data will still be active in S3. And once the node, you get restart one more node, you can actually start that job wherever you left with the same data. So this is one of the huge advantage of decoupling compute and storage, and that is how it is most ideal for EC2 Spot. One thing I just should mention here in this slide is S3 also gives you a lot more advantages, some of which Alex also mentioned. So one thing I would just like to add there is there is no need for data replications in S3, and it is generally good for traditional MapReduce. Moving on. So today we'll be covering self-managed Spark with Yarn and Kubernetes. So Apache Spark is an open source distributed computing framework. It can process large amounts of data by taking care of parallelization of the work across a cluster of machines. It, however, needs a cluster manager, which sometimes also is called a scheduler, right, to manage the machines in the cluster. There are 4 different cluster managers which Spark currently has. It is its own standalone cluster manager. It can use a Mesos, it can use Yarn or Kubernetes. Today we'll be covering Spark and Kubernetes and Spark plus Yarn. Though Spark plus Yarn is the most commonly used combination till date, Spark plus Kubernetes deployment mode is gaining traction very quickly. We have noticed that more and more customers are moving towards that direction. I'll take a pause here. If you have some question, please post it in the chat channel and my colleagues will be answering them. Moving on, Spark with Yarn. So here the Yarn plays the roles of the cluster manager or the scheduler. This is a very secure way of deploying Spark jobs because we can take advantage of the Kerberos. It has external shuffle services. However, there are some shortcomings in terms of isolation and reproducibilities. So one shortcoming is dependency isolation. So when you say dependency isolation, all the apps should run the same version of Python. In terms of performance isolation, we can see if somebody is kicking a big job in the cluster, sometimes the job that is run next tends to run a bit slower. There is a challenge of reproducibility because once you set up a Yarn cluster with all the configurations, the library, and the settings, it is difficult to reproduce the same in another cluster because of managing the dependencies, etc. However, if you are planning to run Spark and Yarn on EC2 Spot, there are a couple of recommendations that we have. For long-running clusters, we recommend that you run the primary nodes on on-demand or reserve instances, and you run the secondary nodes on the Spot instances. By secondary node, we mean the worker nodes. And if you're running a transient cluster, you can go ahead and run everything in Spot instance, 100% in Spot. So when I say transient cluster, if you're very cost constrained, or you are running something for dev, etc., you can actually use this. Another recommendation that we have is you should decouple storage and compute by using S3 when you are using Spark with Yarn. Moving on, now we will discuss Spark with Kubernetes in details. And I will spend some time on this. So Spark, actually, this is the latest cluster manager which was added under the Spark ecosystem. So here Kubernetes plays the role of cluster manager and the scheduler. It is still experimental, the scheduler part at least. It was launched in Spark version 2.3. Some of the advantages that you get here is ease of deployment. Containers makes a life a lot easier, as everybody must know, as they're portable, easy to manage dependency, and they're also reliable. When you are running a Spark job on Kubernetes, it allows for optimized resource sharing. So when I say that, what I mean is that when a job runs and it completes, it very quickly releases the resources for the next job to run, or the parallel jobs which is running in the cluster. It is very secure. Here we can use the role-based access control of Kubernetes to run the jobs, to run the Spark jobs. It is resilient by nature. The jobs which are running on Kubernetes when Spark is resilient, and this has been slightly enhanced in the latest release of Spark 3.0. If you think in terms of EC2 Spot, so if you're planning to use EC2 Spot with Spark and Kubernetes, now there is a feature called pod template, which we'll cover in the demo, where you can actually schedule the driver pods on-demand instances and the executor pods on Spot instances. And we'll discuss the advantages of that in the demo. Lastly, it allows cluster auto-scaling and dynamic allocation soft. I'll try to explain that to you. And if it is correctly configured, Kubernetes will give you a huge benefits, cost benefit of a shared infrastructure. So generally, dynamic allocation in Spark, when you say it comes along with external shuffle, right? Where when a particular executor can be released by a job so that that resource can be used by another job's executor, something like that. And they use external shuffles for it. External shuffle is still not enabled in Spark plus Kubernetes. It is in their pipeline. So what they have done in the latest release is they have done something called dynamic allocation soft, where you can still do dynamic allocation, but it is not dependent on the external shuffle, and it will only consider those executors for scaling in or out which do not have any shuffle files associated with it. So now coming to some of the recommendations with Spark and Kubernetes, and when you are planning with EC2 Spot, run the drivers on demand or RI instances and executors on Spot. How to do that, I'll cover in the demo. And again, we should decouple compute and storage, and we should use an object storage like S3 for that particular purpose. With that, I'll quickly move on to the demo. Any questions, if you have, please feel free to post in the chat channel. So let me know if you can see my screen now. Somebody from AWS team?
Yeah, I can see it.
Thank you. So I'll start the demo. So what we have here is an EKS cluster where we have launched an EKS cluster. Under that cluster, we have two different node groups, which will come in 1 minute. So we have defined two different node groups, one on-demand cluster and one on EC2 Spot. And we have labeled them as on-demand and EC2 Spot. This we will be using. I'll just pause here a bit. This we will be using for the pod affinity purpose in the pod template. We'll go to that in a bit. A couple of things here to mention: the instance type. If you see under the Spot node groups, we are actually using a diversified instance, which is a Spot best practice. We are using a Spot allocation strategy of capacity optimized, which is again a Spot best practice. Now moving on, just a minute here. Yeah. So now this is the way we define the pod template for the driver. If you see the pod template for the driver, we have mentioned the values of on-demand, and we're using a hard node affinity here. Similarly, for executors, we have mentioned Spot. So what it allows us to do is we can schedule the Spark driver on an on-demand instance and the executors on the EC2 Spot instance. If a Spark driver dies, the entire job has to restart it from the beginning. However, if an executor dies, the Spark driver can actually relaunch another executor with whatever job which is left, or whatever shuffle files was required to be recomputed for that particular executors. So by using different types of node groups of on-demand and Spot instances, what we are trying to do here is making sure that the job finishes on time, and even if we're using EC2 Spot instances, which will give you up to 90% of discount while you are running the Spot jobs so when you are running Spark jobs on Kubernetes cluster. So moving on. This is the definition of the executor pod template. Now I'll show you the nodes in the cluster. The auto-scaling groups in the cluster. There are two auto-scaling groups, one running on demand and one on Spot. This also has an advantage, is that when you are launching new jobs in this particular cluster, the driver is not dependent on the resources. It has its own resource set that it can scale up and down, and the executors have its own resource set which it can use. Now, this is how we are submitting the job to the cluster. We are using a deploy mode of cluster. We are having 10 executor instances. Again, we have built our own image for this particular purpose. This is how we mention the pod template files, the driver and the executors, so that it can use the node affinities, etc. And we are using this configuration for the driver memory. We are using S3 for loading the script, the algorithm or the script, and also to write the output back. The script is very simple here. It's just a word count algorithm which is running on a bunch of Parquet lines. So now you can see the job is running. And now I'll quickly go and explain to you the different pods. So we have 10 executors which is running, and these all are running on EC2 Spot instances. We'll show you now. If you go to the dashboard, EC2 dashboard now, if you see the instances, you will see a bunch of Spot nodes which is running under this cluster. And there'll be one on-demand node, because that's how we configured us node groups as. And all these node groups are running on EC2 Spot. If you see the life cycle, right, only one is running on normal. Now, coming back, this is just a check to showcase that all the executors are actually running on Spot instances. So though we get and we filter out the executors and 10 executors and show you that they're running on Spot instances. The next thing what we will do is to simulate a Spot interruption, and interruptions happens by design. We'll actually terminate 2 of those nodes. So what will happen is a couple of the executors will get killed. And then Spark will realize it. So basically, what you see, the executor number 4, 9, 8, and 2 will actually get killed, and Spark will the driver will realize it, and it will relaunch those executors. And we'll see that in a couple of seconds here. Here, yeah. So if you see here, you see executor 11, 12, 13, 14 come up to replace those 4 executors which got killed because we actually terminated 2 nodes. Because this new executors was launched, what will happen is immediately the ASG will understand some of the nodes have gone, and it will trigger the new nodes to launch these executors back. So you can see that one new node is getting initialized. A couple of points on the log files here. So I'll just pause here for a couple of minutes just to explain this. So one thing is that this is a log file of the Spark job. So even if the executor is failing, this is not getting counted as the maximum number of failures for the task, which is important because there is a threshold after that the driver gets kind of killed out. The second thing which I must mention here is that the shuffle file gets lost for the executor, but for executor 10, if you see the yellow box here, but the driver is able to identify them and resubmit those shuffle tasks into a new executor which comes up in the cluster. So moving on, 1 minute. Yeah. Moving on, I have one slide just to showcase the auto scaling and how it works. If when the pods are do not have enough resources to get scheduled in this cluster, auto scaling will get triggered, and we'll have the nodes which come up. So if you see here, upcoming nodes to actually make this pods from pending to the running state. I'll restart. So even with the termination of the nodes, we see that the job finished and on time. And so what will happen is that we will require only a bit of more time for the executor to complete. So that is, but overall the Spark job will complete on time. It will take just slightly more time, even if it's a spot interruption. So after the job finishes, you will see the outputs, whatever it is. So now here we have the outputs in S3. This is the output files we want to show. So that brings to a conclusion to this demo, Spark and on Kubernetes and on EC2 Spot. And I pass on the control to Aparajita. Aparajita, if you're there. Aparajita? Hello.
Yeah, Kinner.
Yeah,
I think
thank you.
want to transfer to me.
Sorry.
Okay. Yeah. Okay. Thank you, Kinner, for doing the wonderful demo. And if you have any doubts here, then I think we'll share the recording after a few weeks that you can go it over. This stuff's a little bit stuffy, so don't worry if you don't get it at the first go. With this, what I'll do, I'll share my screen and we'll get started from here on the AML side. Okay. So hello again, I am Preetham. I'm Senior Solution Architect with the EC2 Spot team. And thank you for staying back. And I see some of the names from the first and second event, which is great. So what I'll do today, I'll take 35-40 minutes time and we'll just barely scratch the surface of machine learning because this is a vast topic. So I want to make sure that when you go home from there or you're staying home, so you take something, you learn something from this and then build on top of that. So when you think about machine learning, what comes in your mind first? Chatbots? Or think about some recommendation for dresses, shopping, for music, for video, fraud prevention. So these are the specific applications which are based on machine learning and typically well known as artificial intelligence services. Think this as very high level services that are ready to use without worrying about underlying technologies. Now, what lies beneath? Think about algorithms, frameworks, machine learning datasets, training, deployments. Think about machine learning frameworks like TensorFlow, like PyTorch, like Apache MXNet. Think about algorithms like XGBoost, deep AI forecasting, linear regression. These are the few models that you need. You also need the deep learning AMIs, which lies beneath to give you the services for machine learning. So these two things, AI, ML, are kind of hands on gloves, you can say. Typically, if you see how this machine learning works, think about that for machine learning, you need huge sort of data. And machine learning essentially refers a large set of algorithms that can solve a certain problem when trained. That means you need data, you need a training, and you need lots of data. So what you need to get started? First of all, to get started, you should know what you are trying to achieve, right? Because there are different algorithms, there are different frameworks. So you should know what you want to solve. And then you start with formulating a problem. So data acquisition is the first phase where you get the data from different sources and you curate what kind of problem you need, and you also label your data. Now, for real life, think about that you want to make a machine learning project using real-time data. This can be from the gas and oil fields. This can be from your phone locations, your internet users, or can be some like tweet feed or something. So that means you need some raw data that may come from different sources. So you need to get the data and have it and level them. That's the first phase. Now, once you get the data, you just cannot use it directly, right? Because this data is unorganized. This could be images, that could be text images, this could be PDF, this could be like JSON data, and they're like extremely large value. So you need to clean the data before you can really use this for your training purposes. You can also think about that. Let's say you get vegetables from the farm. You just cannot cook them, right? You need to clean them, chop and dice. Then it is ready for your cooking. So think about the second step is like very important step here. So this step determines how the quality of your model prediction will be. Think about tools like ETL tools, actually. Think about EDA tools like exploratory data analysis tools, which kind of takes care of the step. Now you have solved the first two portions of your machine learning job. You get the data, you prepare the data looks good. Now you comes to third phase where your all training phase starts. So think about this box, these two blue boxes, design, run an experiment, and model development. This typically works with the training part of it. So you have got algorithm, you have got your computational resources, and then you start training your model. Now model can be trained with a very high accuracy rate, but for that it needs tremendous amount of computational power. It needs lots of GPU. Then you plan to run some experiments to see these models are well trained or not. You check for accuracy, you tune the model, you debug that. And so once you think, okay, this model looks good to me, let's go and deploy to production and see. Then you take the model and take it out and deploy the model, and you keep on optimizing it, which is the last phase of it. But then think about once you deploy the model, this is not the end model, and the model can become stale. Think about the Nasdaq or the sites which does a trading. So after each day of trading, they have to reevaluate the model every night. The bank has to do analysis about their transaction processes every night. So think about that. You teach the system every day and then take inferences on the next day. Think about the real estate giants who does analysis about the market trend, about the real estate prices, right? So they have to keep on training. So that's blue phase, keep on training. This data keeps on coming. Model keeps on training, and the model keeps on deploying a new model day in, day night. So this process keep on running, and this is kind of how machine learning in a nutshell works. Now, if you want to see how it translates to the SageMaker of the part of the world, I will come to SageMaker a little bit later, actually. Think as you as a data engineer or a scientist, actually, and you use a tool like Jupyter Notebook, or you can use a CLI, actually. Now, if you haven't heard about Jupyter Notebook, it's kind of open source web application, which allows you to create, modify, share documents, which can have live codes. You can visualize things, you can run them, you can save the state. You can do lots of stuff there. You can do data cleaning, you can do transformation, numerical computation, and all other things that a typical full-fledged IDE gives. It's a kind of, you can deploy that in a simple instance, actually, and get started from there. Now you get the data, you write the algorithms, you train it, actually, and then you get a model. Now this model, to train the model, typically what you do, you typically use 80% of a data set. So let's say you have got 100 rows of data. You don't train the model with 100 rows of data. You take 80% of it and train the model. And then with the 20%, you check them, actually, how they're doing. So you first train them, and then you put them to test the model, how the model is doing with the rest of data. Is the model doing great? So now you know that the model is ready for deployment, right? So what you do then, you take the model and then deploy the model to production or stage or any environment. Now this model, it can be an endpoint. You can attach the model to any other softwares, what you're running there. And then the live data is coming and taking inferences from this model. Now this looks so simple in this page, but when you try to do that end-to-end, it becomes extremely complex, because the need of hardware is a big thing here. So once you want to do a whole machine learning setups, the setup can be pretty complex. So if you see the key challenges that the data scientist, the researchers, or the developer face is to set up the machine learning pipeline. And then we'll talk about a little bit about how SageMaker can help, and then how containers addresses these problems. So if you're a developer or researchers, so you need 4 ingredients here to start with the machine learning. So first of all, you need access to compute in terms of GPU and CPU, GPU being the graphical processing units. Then you want to access to storage so that you keep on your training data sets and also train your models, the metadata and artifacts you want to save, right? Then you want to access to some source control so that you can track your changes, you can collaborate with other people, and you have a source control tools in your life cycle in place, right? Then you need some optimized machine learning framework. So can you take advantage of the GPUs and CPUs that are allocated to you? Now, if you come to AWS part of the world, this compute typically transforms into P3 or G3, G4 instances. And then the storage could be EBS, which is attached to the EC2, or it could be S3, where you store your data and artifact. And for the source control, it could be GitHub. It could be the ECR on the part of ECR at a part of like so AWS, or the machine learning framework that at the SageMaker or other open source that you typically get. Now, this fourth thing, the 4 ingredients, is you can start doing it in your machine. Pretty much developers used to do in their own machine, and then they could see that are able to do it in production also. But that's not the case. It happens. So once you do things at your end, and once you try to scale it out, that's when problem comes. So think about what is the biggest problem that comes here. Think about that at very high level, software management is the biggest challenge, because this open source machine learning stacks are incredibly complex. Because we know the range of support we give for the CPUs and the GPUs. And then there are libraries, there are instruction sets for this hardware. And on top of that, even these frameworks are changing so fast. So it's become typically lots of combination to maintain, which is very hard if you want to do it yourself. Now, this developer or data scientist, they are not hardware experts. So for them, it is very hard to keep a track of the latest libraries or latest drivers. And then what happens, they're not typically able to get the best performance of the hardware that they are using because they're not hardware experts. Third would be like training the model. Let's say you are writing some code and now you want to share the code. Now your stack can be much different from the stack other people are using. Just by sharing the training code doesn't work here, right? Because there are lots of dependencies involved. If you have tried out things out there, you know what is the problem I'm talking about. So that being a third and big problem. And now the fourth problem is that the scalability. When you want to really, as I told you earlier, machine learning needs lots of data. It's like terabytes of data for a good learning project. Now that much data needs lots of compute power to track things, run things. That typically cannot be done in a single machine, right? In that case, you need some big cluster. Or there are many other factors that comes when you start the training process. You need hyperparameter experiments. You want distributed training. So when you mix things up, you see the step becomes so complex that many small companies cannot start with that. Typically for startups, it is a very hard problem because they see it's like very big challenge to start with machine learning. So how you solve the problem, right? So we know this problem because Amazon has seen the problem, seen the long time. So what we have done, we have something on the AWS stack that makes things much easier for you. We call it SageMaker. So SageMaker is a tool. It's an end-to-end tool. We'll go through the tool a little bit in detail in the next few slides and also during my demo. So you typically can do anything that is possible with machine learning with SageMaker. That means you can build, you can train, you can tune, you can deploy a model, and you can optimize the model, everything about it. It is a low cost and it is just easy to use. So for somebody who doesn't want to take care of all the steps of running machine learning pipeline, just want to run the algorithm, is the best place to start with. The models that previously took lots of time, even months for customer, they are doing it in weeks and even in like days in SageMaker. I'll take one example, the financial company Intuit, you have heard about it. So they have a workload that they pull years bank transaction to find what are the deductible for their businesses. And typically it used to take them like 6 months time. So half of the year they used to do, get the deductibles and find out the tax benefits and all. But then with machine learning, with SageMaker, they're able to reduce the development time by 90%. That means they're saving time, not only the cost, but also the time from 6 months to a week. In less than 2 years, we have more than 10,000 SageMaker customers who are working on machine learning and making some excellent products, which otherwise would not have been possible without the stack. So to see how the stack looks like, actually, think about the famous infrastructure as service, platform as service, software as service model kind of thing. So if you want greater flexibility, if you want to do everything of your own, you can choose your own framework, you can choose your own infra, then you are responsible to running your models also. You run your whole pipeline, you get the data, you, excuse me, you run the inferences, you choose your infrastructure type, excuse me, and you get done with that. That means you are running everything of your own. That can be a little bit like time consuming, but then SageMaker can help you with all the processes. Like you have ground truth to label your data. Then you have notebooks to write and run your code. You have got more than 200 pre-built algorithms to just use from a SageMaker console or API, or just use the marketplace. Then you have got reinforcement learning, you've got training where you don't have to maintain the instances. SageMaker can start the instances for you, stop them, you just pay how much you use. Then you have got model optimizer that makes sure you get the best model for your deployment. And then finally, you have got the SageMaker endpoints where you can deploy your application in a highly available manner. Now, before hosting, you want to do some A/B testing. You want to see how this model is behaving better, or out of the two models, which one is behaving better, you can do that. Then you can have own personalized mini version of the deployments using the multi deployment in SageMaker. So lots of option comes that you want to use. You want to use the services and get done with that. Now there are many AI services which are built, which we offer as part of our AWS AIML stack. Think about text track to get text from images, actually. Lex for chatbots. Think about recognition services for images. You put an image, it says about the image. It's a day, it's night, it's how many people are there, they're happy, they're sad. Then we have got recognition video. Then we have got Poly for voice transcript, actually. Then we have got forecasting, we have got personalized. So these are the AI services I talked in the very first slide, actually. If you don't want to build your own service, you just can come and start using those things. So SageMaker can help you. It can cover for your end-to-end ML need, actually. So typically we have seen data scientists who typically tune the algorithm, or the engineers who make the infrastructure available, they are getting a benefit from it. So SageMaker, what it does ultimately end-to-end things for you. It can do auto-scaling, it can do performance health checks, it can do, if some nodes are getting failed, it can get you more nodes, then it can apply security patches. In a nutshell, it does everything for you. And it also gives you algorithms also. So it has got its own built-in algorithms, and then there are more than 200 algorithms in the SageMaker marketplace. So there are companies who have built their algorithm, so you don't have to run the algorithm of your own. You can save money if you think somebody has just done the algorithm. You go and buy the algorithm, you pay per hour basis charges or some license cost, and run them on SageMaker. So you are just utilizing somebody else's effort for your work to see which one fits you most, right? So these are the things that is very high cost to develop actually, but you can just get started with that. So that's been the SageMaker. Now, coming that the part I have told that when you do machine learning, this is the complex process. It needs lots of computational activity, and it needs lots of computational power actually, which is very hard to find, hard to match. Now, how you can save money here, right? Think about that a bank who wanna do machine learning work actually, and they kind of have to run only those machine learning jobs only for few hours a day. So they're not 24/7 works, right? So purchasing hardware on premises is not an optimal thing to do. Even on cloud, buying reserve instances or savings plans won't cut for these training jobs because they're ad hoc kind of thing, and you just cannot plan them as your growing need. So how you keep the ML cost down? So here are we to save money for you using EC2 Spot instances for training jobs. So in SageMaker, we have got a managed spot training, which use EC2 Spot instances to run your training job instead of on demand. So you can specify which training job should be using Spot, which should use on demand. You can have a stopping conditions actually, and how long SageMaker can wait until it finds the Spot instances. Why Spot is typically important here? Because when you think about SageMaker actually, you think about these training jobs that typically need instances like P3, P3DN, G3, G4, and this comes at a very high cost. If you think about the costing in EC2 pages, these are the highest cost instances. Some of them even cost $30, $34 per hour, and they're really powerful. So if you want to procure them from your on-premises or buy reserve instances for that may not be optimal thing for you to start with. Maybe later, right? So at this point, Spot can be great fit for your workload to start with machine learning training jobs. So what you can do, you can configure you can configure your checkpoints so that if things doesn't Spot interruption happens, you can just resume the jobs. You typically save 90% here. It is ideal for jobs which are not time sensitive. You have time to complete the job. It's not this definite start and end that you have to do the job in 2 hours. Not like that. It can be distributed between one node and multiple node, and then it can, if a termination happens, if an interruption happens, SageMaker can automatically do the things for you. You don't have to worry about that. With the checkpointing, it can put the thing necessary, and again, when Spot is available, it downloads it, resume the process. I'll show it to you when I go to the demo or like kind of demo part to show you how much you can save with SageMaker and how easy to just include Spot for your training actually. So the next slide is about the consideration. Obviously, when you think about running things on Spot, you have some consideration, right? The number one is checkpoints. So if an interruption happens, so you don't have to start your job from beginning. Now some job can be running for 8 hours, some job can run for like a day or more than a day. And you don't want to get started again, right? So checkpointing is the foremost thing here. So many of the algorithms supports checkpointing, and if they don't, the job restarts. The job typically can choose only one type of instances. Like you can have a single size of instances that typically you can run your job. You can pick like P3 and 8XL, 2XL kind of thing. And then when you checkpoint, each time you checkpoint, your data is saved to S3. And then when again your termination, if a termination happens, it can wait for a certain amount of time before you abort the job actually. So you can have lots of options actually inbuilt that can help you. Like, let's say you don't want to wait for a longer period of time if you don't have checkpointing. So you can have a max wait time 60 minutes set. So if there's no checkpoints and you don't get a spot for 60 minutes, you just abort the job, and then you can have a lambda to retry your job in some other instance types maybe. For the pricing, you get roughly 70 to 90% off of the on-demand prices, and you can see it in the console. You can also see the billable hours when you show to you actually. So typically, if you want to see the workflow, it is like pretty simple workflow. So you go to console or your Jupyter Hub notebook, you just enable Spot training true, you give the parameters actually, and you are training only with Spot instances. Now, if there no interruption happens here, you happy, you complete the job. Now, if an interruption happens, it may happen at 1 minute or any minute, or maybe end of the day, or may not happen, right? So if an interruption happens, you wait for the spot capacity. So if you wait for the spot capacity, you can have a max wait time set. Let's say you said, okay, I'll wait for 60 hours, or I'll wait for a day actually. If the wait time exceeds, you go and terminate the job. If no, then let's say again Spot is available. Like Spot is again, right? It's a matter of like supply and demand. So if Spot is available, most of the time they are. But in the case of P3 types and G4 types, they're extremely volatile pools because lots of machine learning people are trying to access the pool and then Spot. So that may keeps on changing the availability, right? So especially for machine learning, other workloads, they are pretty stable actually. So if Spot is available, it checks, do you have a checkpoint enabled? So if I have a checkpoint from where I can restart my job or resume my job. So if the checkpoint enabled, you just resume the operation and get started with that. And again, you launch Spot instances and you complete the job. If checkpoint was not done, then it restarts the job. The simple workflow actually, which you can, it looks like a very simple workflow, like day-to-day type also, right? So if you want to go for example, actually, I'll give example of Cinnamon AI actually. So this company, no, actually, Cinnamon AI. So what they have done here, so they, as a like Japanese company, they have done they have their own products like flag scanner. Their goal is that they want to get rid of the human jobs which are like repetitive, which are not funny, which are not like fun to do, right? So what they are doing, they've created a few AI/ML power tool. The flagship product is like Flag Scanner, which is like natural language processing tool. It can read unstructured documents like invoices, receipt, insurance claims, financial statements actually, and find the relevant data. So if they started running with EC2 on demand, and then they started running with SageMaker actually. You see, once they start running with SageMaker, that too only with on demand, they instantly save 20% of their cost saving because SageMaker algorithms are optimized actually. There are algorithms which are available on the open market. The SageMaker team has got a dedicated team who have optimized the algorithm for you. That means it takes lesser time to complete those things. So immediately using the same algorithm, which is optimized, you save 20% on top of that. And then using managed spot training, they are saving up to 70% of the earlier cost actually, which has been a huge amount of money if you see how much money goes into the machine learning training. Now, if you're interested with the algorithm, how they built it actually, so they're developing multiple ML powered tools, as I said. So the data that comes, there comes in multiple forms. So the data comes as like 2D images, sometimes the audio, sometimes the text, and sometimes it's data, right? They're of like images also, sometimes video files, audio files also. And that can range from like few hundred MBs to like 40 GB also, what they said. Now they use some deep learning framework for this. They use TensorFlow, the PyTorch, and they use GPU instances for their time-consuming neural network model. Now this some jobs can run for few hours, some jobs run for days. And then if they have a smaller job, they just use CPU for that. So here, how they have set up the whole system. Let's say you are here as a developer or researcher of the workstation. So what they do, they have created a always on EC2 server actually, where they have enabled SageMaker local mode. So they run their code on Jupyter Notebook or something, and then they push their code to the local mode to test and debug the script with a small set of data. So this data set is really small. They test the algorithm if syntax correct, if they're working well. And then if they're satisfied, they push the algorithm as a Docker image. And that goes to Amazon ECR. Now, this Docker image is pretty important because once they put in Docker image, it's very highly available. And other people can use the Docker image and can start working on that, right? The Docker image consists of all the things that is needed for your machine learning job. Now, once things are there, they can also, from this machine, they can also ask the SageMaker SDK to run the managed spot training. So this managed spot training takes the artifact from S3 and they load the data from S3. They checkpoint the data after some time, and then start the training process here. Now, sometime you may say data loading from S3 could be slow. So what they have done for that, if you need data at very, very high speed from S3, you can use FSx4 Lustre actually. So FSx4 Lustre takes care of the data time, reduced data time loading actually. And then if you have a failure, you can resume the job from there. So typically it is an end-to-end workflow, and then they have got CloudWatch, you have got CloudTrails to understand what is happening on the back end. Typically for Cinnamon AI, everything is running on actually Spot right now. So they are saving up to 70% in their case. And we have seen other companies also, they started using managed spot training for their workload. So what I'll do here, I'll just quickly show you how you can see things in console. So if you haven't seen it before, SageMaker is a tool for end-to-end pipeline tool. You go to AWS console and type for SageMaker. And I won't go to SageMaker in detail. I just will show you what is needed actually. So you have got ground truth, you have the notebooks. So I'll be typically interested in my notebook instances, what I am running one today. And I'll also interested in training jobs. So you go to SageMaker. I have got a Jupyter Hub notebook running actually. I'll open a Jupyter notebook and it will take like less than a minute to start. It is already running actually for me. And I have got a notebook running that I ran already yesterday because it takes time. So I ran the notebook yesterday to show you the results. So I ran a job yesterday for the fraud detection, and I'll show you. So what it does, it takes the data sets from here, it's import NumPy. And what I am typically interested is that how the training is done. So here what I am doing, I am training with an on-demand instance, okay? And I am choosing my instance type. I'm saying how many instances I need. I'm saying 1. I'll make this a little bit bigger actually. You can see it correctly. Yeah, so training instance is 1 and instance type P3 to X large. ML says the ML based instances. It comes with some attached volume actually. And I put a job name, training on demand, and the predictor type is the binary classification. So I got the data earlier steps. I'm not going there. So I am running this with the on-demand instance. You see the job runs and it takes roughly 12 minutes time. So yeah, so the job training seconds 739 and billable seconds 739 because it's running on demand. So SageMaker takes care of starting the instance for you, download the artifact in the box and then run that. You don't have to specify anything else. You don't have to start the instance of your own, then put the IP addresses there and do the things. You also cannot see the instances in your console actually, because it is happening at the managed SageMaker end. So you just calling the compute, get done with that. That means you're not managing anything about the compute here. You're just calling the compute, working on that, and paying the bill, which is 739 seconds. Now with the, if you want to use the managed spot training with SageMaker, you just have to add few parameters. Think about this one, and I have just added few lines here. So what I am doing, I am writing some more codes here saying training using spot instances true, max runtime and max wait time. And then what I am saying, okay, one instance type is same, and that's all. Train using spot instances, yeah. And so I am just getting the values from here. I can just write these values here also. I'm just putting the parameter here to explain you what new changes I am doing. So just I'm calling this value here, and I'm keeping everything same. Now, if you see, it says starting the training job, launching requested ML instances. So that means preparing the instance for training. That means I requested the box at 4:52. I got the box. The box got started at 4:54. So that means I got the instance actually immediately. There was the instance was available on spot market. If it would have been like this, it will wait for the amount of time that I have mentioned here, right? And then everything is simpler. Job runs here, and you see this job ran for some more time actually, and then the training ran for 844 seconds in this case, but you are only billed for 253. Now you may ask why I am billed for 253 only, right? So this is based on the right now the spot price, what is for this P3 P3DN in the availability zone actually. So now that is available at 70% discount. Roughly this fluctuates between 65 to 90% discount. 70% is an awesome saving actually. So based on the pricing, you are only billed for this many seconds. So that means you are saving around 70% of the on-demand price for that. Now, if you are UI enthusiast, and this last part is like I am deploying that again for another box. Now deploying, when you have the model, you want to deploy somewhere, right? We deploy with endpoint. So for deploying, I will be using different kind of instances, because deploying, that means now the model is ready, and now other softwares or other APIs will call this model and check about like if there's a fraud or not, if or something like that. That means lots of small requests will hit me. So that needs a typically different kind of hardware altogether. We have seen that until now we have got this M type, which is like generic type, or T type, which worked best for them. But then last reInvent, we launched something called Inferentia chip, which is called INF1. So in each box, you have up to 16 INF chips, and these instances are made for machine learning inferences jobs. So you got 40% more power, and you get the elastic GPU capability there if needed actually. So lots of new things are there. If you really haven't heard about Inferentia, just go there and check about INF instance type INF1. So if you are more into UI, you come back to your SageMaker console and you go to the training jobs. See the training job that I ran yesterday, like one with on-demand. Yeah, so this one on-demand I ran, the same thing you can see, start time, end time, and then training time and billable time. There's no savings because I ran on demand. You can see more of the things like additional volume type that comes with the machine actually. With 30 GB, you can have extra volumes also if needed. Then you see the S3 data sets where they're uploading the data, and other stuff here. Okay, and then other matrices, which is like CloudWatch is integrated with the SageMaker. You know how much memory utilization happens, so you can optimize things. So I am using P3D and right now P3 instance type 2XL right now, but if I see lots of CPU utilization happening, so I can take care of that later part of that. So I can maybe use a bigger instance type or something based on the graphs I'm seeing. Now, same thing, I am deeply interested here. There's no savings here, right? Same thing, I ran the job I showed you earlier with Spot Instances. Now, if you see, again, the billable time is 253 against 844, and you are saving 70%. Rest, everything remains same, actually. So it's kind of, think about this, you just by including few lines, and by enabling the checkpointing, you are kind of saving the up to 70% for your workload, and without doing much hard thing. So that's why it became immensely popular, actually. So I'm 40 minutes up. I think I'll take 5 more minutes talking about the containers. So I like prototyping on my computer, same like you do, right? But then why I want to collaborate things, I use GitHub, and then I see challenging. So let's say challenges, I will say first, I may run a distributed training or a similar kind of training, which need lots of different variation of it, right? And making variation over a machine is not possible. Then let's say me and you are working on that, and I am sending you the code. It's not running code perfectly in your machine because there could be simple variation here and there. And with machine learning, there are lots of variables comes into picture. So you may use a different version of TensorFlow, or maybe a different CPU architecture, or some different algorithms, a little bit version here and there. So it becomes very non-consistent from person to person, right? So it makes problems. Somebody will say, why not use Python environment? Python is great, and the virtual environments are great, but they're good partially. There are several non-Python dependencies that you cannot port with those things. And due to the complexity of typical machine learning stack, a large portion of the dependencies like hardware out of scope. So you need something to manage your cluster, right? So if you want to do everything of your own, this is the hardest thing to do. It's a DIY model. Getting started is easy, but scaling is typically hard. Then we have a model where you use containers. So for containers, you can use Kubernetes, you can use Amazon EKS, or you can use ECS actually. Kubeflow is a very, very well supported thing on EKS. So for your machine learning pipeline, starting is hard because containers containers has got a learning curve, but once you are there, scaling is super, super easy, right? And if you don't want to take care of those things, then you don't want to put effort on the scaling part of it. Just you want to concentrate on your optimizing your architecture, just use SageMaker. So it is a fully managed thing. No infrastructure effort is needed. You just saw in the demo what I showed you, right? You just call the instance, that's all. You can ask 10 instances, that's fine, that's all. You don't have to worry about that, from where they're coming and how they're coming, what is the underlying networking part of it. You just call them and get done with that. So typically, containers for ML looks like this. You can have TensorFlow, you can have many other frameworks. You can have NVIDIA also for this. I will not go through this. If you want to do something else, you can do, like, you can take the deep learning containers that we have announced, the frameworks we have, take the container and get started with that. It will help you marginally saving 30-40% time rather than making things of your own, right? If you want to use EKS, great. There's a very good Spot portion that, so in our last webinar, we have talked about how you can use Spot with EKS. And this is the way you can save lots of money if you don't want to use SageMaker, but you want to do things of your own. So you develop things on your local desktop laptop. You have your custom containers. You can have the AMI that is chosen, that is available on AWS, or bring your own AMI, make Docker containers out of it, and then push that code to ECR. Then from there, you start a whole cluster of EKS with Spot instances, and then you use S3 and FSS for Lustre for faster getting data. If you want to read more about things, how you can use Kubeflow, Katib, or EKS, there's this page you can go and read more about this. If you want to do some hands-on, there's some distributed training workshop on AWS. You can start working with that. I have also attaching 2 videos here, which will be helpful to you going forward if you want to work on this. There's some resources as usual in our what we have showed earlier also. There's a mega tutorial. There's some example notebooks. This notebook you can download and get started. That being said, I think that's all for today. And I know this is a very, very deep topic, and in 40 minutes and 1 hour for big data, we're just scratching things here and there. But we want to give you a kind of food for thought where to get started. As we say, it is still day one. Every day we are learning, right? With that, I'll open up for question and answers.